This is Sierra Alvin for my Physics 221 Chapter 11 reassessment. What I chose to do was a problem on angular momentum and about the moon orbiting the Earth. Chose this because it's my favorite in lab class. Alright, so we have angular momentum, which is represented as L, equals the moment of inertia times omega, which omega represents angular momentum. So we're given that the mass of the moon is 7.4 times 10 to the 22nd kilograms, and it orbits at a distance of 3.8 times 10 to the 8th meter from the Earth. We're also given that the period of orbit is 27.321 days. What we first need to know is what moment of inertia is. One of the formulas for a moment of inertia is mass times r squared, where r is the average distance between the center of the Earth and center of the moon. First, we need to change the days into seconds to have our units right. So as you see, we put days, and then in 1 day there's 24 hours. In 1 hour there's 60 minutes, and then 1 minute there's 60 seconds. As you can see, the days cancel, the hours cancel, and the minutes cancel, and you're left with seconds, which gives you 2.36 times 10 to the 6 seconds. Alright, then we have omega, which omega equals 2 pi over t, which t is the period of motion. So in this case, we just figured out the period of motion, which was 2.36 times 10 to the 6 seconds. So for omega, we have 2 pi over the seconds we found, which gives us 2.66 times 10 to the negative 6 radians per second, which can also just be written as seconds minus. Now r squared, which is the average distance between the center of the moon and the center of the Earth, is 3.8 times 10 to the 8th meters squared, which equals 1.44 times 10 to the 17th meters squared. You have to square your units along with your numbers. So now we find I. So we just found r squared, and we plug in the mass we're given at the beginning. When we plug in these two, we get 1.0656 times 10 to the 40, which I didn't write the units, but is kilograms per meters squared. And the omega is what we found from the last slide, 2.6610 to the negative 6 radians per second. Then we finally plug this all into the formula. Angular momentum equals moment of inertia times angular velocity. So we plug in the I and the W we found, and at the end you can see we get 2.84 times 10 to the 34th kilograms meters squared per second. And as you see, we didn't need the radians in here, so what I did was I took and rewrote the second as a negative, which stands for the seconds on the bottom.